All right, I think we're about ready to get started. Make sure the stream is up and running. All right, I think we're okay. Looks like I am live. I want to add the GitHub repo into the notes, to the video notes. Okay, so that should be in there now. All right, welcome everyone. I'm just doing this as a weird speed run. So what I'm doing is I'm challenging myself to build out an entire configuration on Arista AVD for 50 plus nodes. I've got a bunch of leaves and spines I've got 50 leaves and 3 spines and a couple border leaves and a couple routers and devices that are pretending to be firewalls. And the only thing that they have on them right now is a basic config. And I'm going to go from that basic config. At least I can SSH into them. But there's no underlay, no overlay, no config. I'm going to go from that to a fully fledged out EVPN, VXLAN, leaf spine topology. I'm going to try to do it in less than an hour for 50 devices. And so that's what I'm doing here. I didn't schedule this. I didn't plan this. I just thought, you know what? I've got some time. I've got some tea here. And I'm going to try to do this. So what is Arista AVD? So Arista AVD is an open source project, and it allows you to build, document, deploy, and validate configurations for EOS devices. Specifically, it can build individual configs, but what it's really great at is building out fabric-wide configuration. So it can do like your standard layer 2 configurations. Arista calls it layer 2 leaf spine. We would call it, or most people would call it probably like a collapsed core. So it's no VXLAN, it's just layer 2 everywhere. EVPN VXLAN, which is probably the most common way that it's used. And then MPLS. You can also do MPLS with it too. And I think they're doing it for their Pathfinder SD-WAN project. But and then I've already done this a couple of times in this environment, but I'm going to do it from scratch. Well, I'm going to use the documentation, but I'm not going to use any of the previous inventory files and so forth. So I want to see how long it takes me to get from A to B. And A is here's what the topology looks like. I've got 3 spines. I've got 48 leaves. There's going to be 49 and 50. We're going to add those later. 2 border leaves, an external router to act like the external routed connection, and then 2 firewalls. And we're going to get them all configured with underlay, overlay, EVPN services, tenants, VRFs, all that kind of stuff. We're going to get all that done in about, and I'm going to try to do it in under an hour using just AVD. So how did I get 50 leaves? Well, I'm running Container Lab. And I've got a gigantic VM. It's got 80 gigs of RAM and 16 CPUs on it. And running on my hypervisor, and it's unable to start it up. So that's where I've got these. So there's not physical systems. So I don't have like 50 leaves and spines in my laundry room. That would be hilarious. So that's what I got going on. And yeah, so it started 3 minutes ago. And let's see, I haven't like tried this out. I haven't rehearsed this or anything. I've just got my knowledge of AVD, my experience with AVD and Ansible. I'm going to run this on top of Ansible. You can do AVD by itself. You can do it just as a Python module, but I'm going to run it with Ansible just because I've been doing Ansible a lot. Yeah. So here's the system. This is running Container Lab, and it's got access. I'm running VS Code as a web app right now, and I've got from this system right here. VS Code is running on this Linux system. It's the same system that's running the 50 plus nodes, so I can SSH to like leaf 40. And right now it's just got a very basic config on it. It's just whatever it was set up with Container Lab. I'm running 4.33. I'm running containerized EOS from Arista. I highly recommend it for practicing with network automation because Arista makes it pretty easy to get a hold of a legal copy of it. You just have to create an account on arista.com and you can download a virtualized container, or you can download the VEOS for a VM or the containerized EOS for Container Lab pretty quickly. I'm using the non-64-bit version because it uses half the RAM for some reason. It's about a gig a piece. So I've got probably 58, 59 nodes. So it's running about 60, 70 gigabytes of RAM. So you need to have a beefy VM if you want to do this. And I've got a GitHub repository. It's in the notes for the show, for the stream, and I'll be populating that as we go along, in case you want to try this at home. And but right now the repo just has inventory.yaml and there's nothing in there. So I will copy. I'm going to get things set up. I will copy the. I'm trying not to copy from existing playbooks and stuff that I've got. I will copy a few things. For example, I will copy the ansible.config file because it's very basic. It's the same one I use everywhere. So inventory files, inventory.yaml, host key checking is false, and gathering is explicit. And what we're going to do is we're going to fill out. So the way that AVD works is you fill out these data models, and they're YAML files, and they're going to be group vars. So it's going to load them up, and it's going to build configs, and then we're going to deploy the configs. AVD can deploy either directly to the devices, directly to the EOS switches, or it can go through CloudVision. I'm not running CloudVision, so we're going to go directly to the devices. And then we're going to test the config. It's got a whole built-in test suite. So after you deploy it, you can run some tests to see if you've got maybe some misconnections or something like that. So we're going to do that. I've set up, so here's the physical topology, 3 spines, 50 leaves, 2 border leaves, and then 3 devices. So that's 50, 53, 54, 55, 6, 7, 8, 58. I've got 58 nodes here. For the logical topology, I decided to go with 3 VRFs. I don't know if I'll put them in 3 tenants or just 1 tenant, but 3 VRFs. And the way that VRFs work is they can't route to each other. So the VRF DMZ will connect out to the internet via R1. So there'll be a BGP peering session there, and we'll announce some routes. And then between the DMZ and internet and internal A, there will be a firewall. That's that external firewall. It's basically just a router. We'll pretend it's a firewall. And then between internal A and internal B, there will also be a firewall. These will be stretched VLANs with Anycast gateways. The only exception is VLAN 202 and 203 will be L2 only. That's fairly common in certain scenarios where you have something else is going to be your first hop. So rather than the fabric being the first hop, it'll be like a firewall or load balancer or something like that. So just to give it a little bit of a variety there. And then our endpoint connectivity, I've set that up. We're just pretending that we've got a bunch of equipment plugged in. I've got some profiles for VLANs, for trunk ports, and then on all my leafs from 3 through 10 will be this profile. From ports 11 through 15 will be this profile. I think it'll take the config, even though the ports aren't really there. We'll see. We'll play around. We'll see how that goes. Again, I haven't rehearsed this. I have an idea that this will work, but I mean, I know it'll work, but I haven't done this. So let's go ahead and get started here. So the first thing we're going to do is so we got the Ansible config file. Now we need an inventory file. So I'm just going to make this. We'll do an all group. We'll do children. We'll have the fabric. So that'll be the leaf spine topology. And then I'll have another one called infra. And fabric will also have groups. There'll be a group of spines and leaves. Now, the group names in the inventory file, they don't need to be capitalized, but Arista typically does that as a convention. It makes things a little bit easier for AVD, so we're going to do that. We're going to keep that convention. They don't have to be capitalized, but we are going to here. And then for spines, I'll just declare the spines under hosts, and that'll be spine 1 through 3. That's it. And then for leafs, that'll be leaf 1 through 48. So we got 48 now. We're going to add 2 later, just to show off. And I think that's it. So far, there'll be some other things we need to do a little bit later. And then for infra, we'll just do hosts. I don't really. Oh, I do have some. Yeah, I do have some hosts in here. So we'll do children, hosts, and then the group actually will be called hosts. It'll be host 1 through 2. I think I have 2 hosts configured. Host 1. Host 2, host 3. Yeah, I just have 2. All the leafs and spines are in DNS. Well, they're not really in DNS. They're in Etsy hosts. So they all have entries. And this was actually inputted in there it was done automatically by Container Lab. And I'll put the Container Lab topology in there as well, just so it'll be in the repo. So I'll show you what that looks like. It's pretty big. And then we're using 4.33.2f. That's the most recent version I was able to get. I think it's middle of April in 2025. Oh, did I say this is May? I might have to change that. I don't know why I thought it was May for a second there. Okay, so yeah. So what I'm going to do now is I'm going to create a quick playbook that is going to just set up do some stuff to make things a little bit easier for me. And I am going to copy this because this is not really part of the... Well, for one, I'm going to create a directory and I'm going to call this playbooks. And then in there, I'm going to create a playbook called setup nodes. And the play is going to run. We're going to run it against every device, and it's just going to be housekeeping. Let's call it housekeeping. So it's not related to AVD directly. I want to do some stuff on here just to make things a little bit easier until I start deploying the configs. Now, something to keep in mind, when we deploy configurations in this method, we're deploying directly to EOS. We are replacing the entirety of the config. So all of the configurations that come from AVD need to be the entire configuration for the device. We can't do partials with this method. If we were going to CloudVision, we could do them as configlets, and then it could just be part of the config, but we're replacing it directly. So I'm just going to do some initial setup just to make things a little bit easier. We're going to run them against all hosts, because it also helped me out for the host and for the routers to have some of this stuff already done. AVD will replace all the other configurations, but we'll do it for all devices. So leaf, spines, routers, firewalls. We're just going to do some housekeeping tasks, like we're going to add SSH key. Use the EOS user. And I'm just copying and pasting this right now. I'm just going to create myself a user account here. And it's going to pull, I've already done an SSH key gen, so I have an SSH key. This is the public key. And it's just going to upload this to the devices, and then that way I can log in without a password challenge. The other thing I want to do is just run a couple of quick configs, and that's to configure authentication. This just means that I'm dropped directly into privilege exec mode, because right now the default is when I go to like leaf 40, I'm dropped into exec mode, and then I have to do enable. It's not a really big deal, but this just means I get dropped directly into privilege exec mode. So I'm going to run this playbook, Ansible playbook, set up nodes. Let's see if this works. Host list is empty. Only local host is available. Oh, I misspelled Ansible config. So it didn't pick up the fact that my inventory file was inventory there. So Ansible. Now let's run that again. There we go. Oh yeah, so I don't have any authentication. I don't have a way to get into the devices right now. So we're going to do that under all. We're going to put some variables, and we're going to put some connection parameters in here that we're going to use for these devices. So we're going to come in as, again, I'm going to copy this. And then I'm going to delete them one by one, and then I'll undo that one by one, and then tell you what each line does. Okay, so for the first thing we're doing is we're doing Ansible user. So that's what Ansible is going to log in as. By default, Ansible was meant to be a server administration tool, but we're going into network devices, specifically a type of network device that's very common called a single configuration file device. So it means there's one file on each network device that has the entire configuration state. So for Cisco and Arista, that's running config. For Juniper, it's something else. But that's typically what we deal with most routers and switches. We're going to put Ansible password in here. Now, of course, it's not a good idea to do put a password in your in your plain text, but it's a lab environment, so it's okay. And if you wanted to secure this, which you do if you're doing this for production, is you can use something called Ansible Vault, or there's other ways to do it too. But so we're just going to do the quick way. Network EOS is EOS. So this tells Ansible that we're not doing a normal logging into a device via SSH and then uploading some Python code. We're going to manipulate the single configuration file. And we're going to connect through HTTP API. So Arista has two ways you can get into their devices, connection methods. And so we can get into, let's say this is leaf 1. We can get in through SSH. So it uses NetMiko or PyLibSSH. So we can go in via SSH if we wanted to, or we can go in via the eAPI. So it's a vendor-specific API for Arista. There's a little bit of an advantage for going in through eAPI, so we're going to do that. And then we're going to use SSL because we're going in through an API, and that API is HTTP-based. It's called JSON RPC. We're going to not validate certs, which means we're going to rely on a self-signed certificate. If you wanted to do a cert authority yourself, you could do that. We're going to use port 443. We're going to become super user, and the method is enable. Now, because after I do the setup nodes, I won't need that last part, but we'll put that in there. It doesn't hurt anything. So let's run this playbook. Now it's going into each device. Now think about how, it's pretty simple what we're doing. I'm adding a user, an SSH key, and then changing some login parameters. How long would it take you to do that to 58 devices? A couple minutes, maybe. I'm doing this in less than, I'm doing this in less than a minute. I could probably speed this up. If I did forks equals 40. So I'm going to run a time command here. It's going to go in and just verify that everything's done. So it took 10 seconds to verify that the changes were made on all these devices. So let's go in Tony at leaf 1, and then I'm logged in without a password, and I'm dropped directly into privilege exec mode. So that's that hash there. Okay, so we're good there. So our inventory file's shaping up pretty good here. Is there anything else we need to do? I think that'll be it. For now, at least. So I'm going to create the other playbooks. Now I'm just going to have 3 other playbooks. I'm going to have my build.yaml build fabric. I'm going to have deploy fabric. I'm going to have test fabric. That's it. So the build fabric, we're going to call 2 roles. And let's go to the documentation. And let's go to... Oh, it's already installed. So I've already installed it. And I actually upgraded the version of PyAVD to pip list to 5.3, which is as of April 16th is the latest version. So AVD 5.3. They made a big change in 4.10. I think it was 4.10, where they moved all the configuration generation to a Python module instead of an Ansible role, and it greatly sped things up. So it generates configs really, really fast. So we'll do examples, and we'll just look at single DC, leaf 3, L3, leaf spine. And we'll just steal their... so this is what their inventory file looks like. So we'll have to add a couple things here in a second here. And then there should be a playbook in here somewhere. We're just going to concentrate on the build playbook to build the configs. All right, so here it is. So that's it. I'm just going to copy this. So we're going to use publicly available stuff. I've got my own stuff to do this. I've already made this stuff, but we're going to do publicly available stuff. So build configurations, documentation. It's done in 2 steps. The first step builds structured configs. So each individual device will get its own structured config. And then the second step is to take those structured configs and turn them into native EOS syntax. But nothing gets deployed. We're just creating the configs. It'll put them into a config directory. Every leaf and spine will have their own configs. So in order to do this, we need to build out things like overlay, underlay, and so forth. And we need that information from the data models. And we need that, and the way that we feed it in Ansible is we feed it through group vars. So all the information about our leaf spine topology is going to go in through group vars. Now there's different ways that we can separate things out, but here's how we're going to separate things out. This is the way that I found it's very easy to follow group vars for AVD. So first off, we're going to have a fabric.yaml file, and that's responsible for the underlay and the overlay configurations. So the underlay will build a simple routed topology that will announce the loopbacks into the routing protocol. So it can be IPv4 or IPv6. Each device will get its own loopback 0 address. So all the leaves and spines will get loopback 0. And the spines the leaves rather will also have a loopback 1 for the VTEP. And all the underlay does is whatever routing protocol you choose, it's going to put those loopbacks. So the underlay, all it does is enable me to ping a loopback to any other loopback. That's all it does. We're going to use the default routing protocol, which is BGP or eBGP. And the overlay, the only thing it does is it peers loopback zeros from every leaf to every spine, so that we can exchange EVPN route types. That's all the overlay does. And there's going to be a lot to it because we have to describe the fabric. We have to describe how the leaves and the spines are plugged into each other. Yeah, so Roxy's a friend of mine. She says, do we place bets on getting this done in an hour? Yeah, I don't know. Who knows? It's an experiment. I might shave off a couple of 20 minutes because I did a kind of a lengthy explanation. And Tristan says, thanks for nerd talk. Yeah, no problem. Yeah, this is just me drinking some tea here. Actually, I might switch to wine pretty soon. So I'll violate a rule: never sysadmin, never network admin while you're intoxicated. But we'll see. but I'm enjoying the tea right now. So we need to describe the overlay and underlay. And then we also need to describe the EVPN services. So let's take a step back. There are 4 parts to any EVPN VXLAN network. There is the topology. That's this right here. What devices do we have and how are they plugged in? What devices, how they're plugged in. Then we have the underlay. Loopbacks into routing protocol. You can use whatever routing protocol you want for the underlay. You can use OSPF, ISIS, IBGP, EBGP. Arista's default is EBGP. We're going to use that. And then the overlay, which is peering to spines, to spines to propagate EVPN routes. So when a host is learned by a leaf, it will create a route type. It will create a route, an EVPN route, and then that will get sent to all the spines, and the spines will propagate that to all of the leafs. In EBGP, that means the spines are going to be route servers. If it were IBGP, that would mean the spines would be route reflectors. So they're going to be that. And then we have the EVPN services. So that's things like tenants, VRFs, stretched VLANs, VXLAN segments, Anycast gateways, external peering, etc. So, and then actually a 5th one, and that'll be how endpoints are connected. So that's the front-facing ports on our leaves. Connected to hosts, hypervisors, bare metal systems, etc. So in the fabric file, that's going to be the topology is also going to be encoded into there. So topology, underlay, overlay, EVPN services.yaml. That's going to be the tenants, VRFs, VLANs, VXLAN segments, Anycast gateways, etc. And then we're going to have endpoint connect. And that's just going to contain our profiles for, like, I've got these profiles here. That's just going to contain that. And then under that, we're going to have each leaf pair gets a group. So that means I'm going to have to go in. And so leaf 1 and 2, YAML, leaf 3 and 4, .yaml. And the reason I'm doing this is if I put all of my endpoint connections into one file, let's do a little bit of math here with the calculator. A typical top of rack switch has 48 ports times 50. That's 2,400 ports that I'm going to configure here. I don't want to put 2,400 ports in a single file. I'm going to do them per pair. When we're doing EVP and VXLAN, we have 2 choices for multi-homing our systems. We could put them into an MLAG pair, which is the more traditional method, or we could use something called EVP and all active, where they're not in MLAG pairs, and we use something called ESI coding, where every port channel that's shared across the fabric gets its own ESI number. It's a 10 byte number. We're going to do the more traditional method, which means that leaf 1 and 2 are going to be in an MLAG pair, and we're going to configure them together, so they're going to get a group. So I need to put in my inventory file, I can't list them out like this. So under leafs now, I have to change this up. So I've got going to have children, which means there will be other groups, children. And then I'm going to have rack 1 and rack 2 and rack 3 and rack 4. And I'm going to have to do this 25 times or 24 times. So that sounds like a job for Python. So I'm going to create a new directory in here called little scripts. And these are just going to be little Python scripts I'm going to use to generate some of this config. I could put them all together into like a helper thing, but I'm just going to make a little script like this will be rackcount.py. So it's just going to be a simple little Python script. I equals 1 while I is greater than 25, print f. What do I want to do here? Oh, you know what? So let's see what we need to do. So hosts, that's going to be leaf 1 and leaf 2. Okay, so I've got a rack counter and then I've got a leaf counter. So I need to do some quick Python code here. All right, rack counter. There's probably a way better way to do this in Python, but I'm just doing this really dumb and stupid. Rack counter is 1. Leaf counter is 1. So while rack counter is less than 25, first thing we're going to do print, do fprint since it's Python 3. And how many tabs do we need? So I'll just copy that number of tabs, and then it'll be rack, and then we'll put in the rack counter, and then rack counter plus equal 1. So that's going to increment it by 1. So let's see if that works. We'll go into little scripts. Or where did I put that? Oh, I'll put it under playbooks. I need to move it out of there. You know, I'm gonna rename it to utility scripts because little scripts just doesn't sound very professional. Utility scripts. There we go. So Python 3 rack count. Oh, then I need to put a colon there. All right, so that looks good. So I do that again. Yeah, so that looks good for that. And then under each one of these, I need to have, you know, by the time if I just copied and pasted this and did this by hand, it would probably have done it. But yeah, so then we'll do this and we'll do another loop. And we'll do odd even counter. So while odd even counter is greater than 3, or where it's less than 3, then we'll do print f. Do 1, 2 for space, 3, 4. Oh yeah, so then we need to do print fprint hosts. Yeah, and then we need to put 2 hosts under there, so we'll do be host or be leaf. And before we start this loop, odd even counter will be as 1. Yeah, we'll do odd even counter 1. And then our rack counter or leaf counter, so it'll be leaf counter. And then we're going to increment leaf counter, increment that counter by 1. There's probably just a way easier to do this, way easier way to do this, but this is what I'm doing. Got 6 people watching, cool. Didn't like my, oh yeah, I need to close that. Holy shit, it worked. It worked the first time. That almost never happens. I swore there, so that's why. So I'm just going to copy that and paste it in there. I didn't have any notes on that. I just completely did that off the cuff, and it worked. And I can't believe it did. At least the first time. I can believe it worked. I just don't believe it worked the first time. So rack 1, rack 2, rack 3. So that looks like it works. I'm going to run that playbook again. And just see, okay, so it didn't like something here. So I'm just doing this to check to see if the inventory file if it liked the inventory file. Well, constructing a mapping, found a duplicate key rack 2. Oh, that's because I left these back in here. Okay, let's try that again. Skipping unexpected key hosts and group hosts. Only vars, children, and hosts are valid. So I'll fix that error too real quick. I think that's under... Oh yeah, so I did it backwards. Hosts. The group is called hosts, and then host there. Oh yeah, there's also routers. And there's R1, and then there's R1, and then there's firewalls. Firewall 1 through 2. All right, let's run that again. All right, so we're making some progress here. Got an error in there. What was the error? Oh, yeah, so that's fine. All right, cool. So look, moving right along here. So my group vars, I need to create, I create a lot of files here. So I need to create fabric.yaml. That's going to have my underlay, overlay, and topology. Then I'm going to have EVPN services, services.yaml. That's going to have my VRFs, my tenants, my VLANs, etc. I'm going to have endpoint connect.yaml. And then I'm going to have, I need to have rack1.yaml. And let's see if I need to do a utility again. Yeah, I'm just going to do a quick utility. I'll call this touch.py. I equals 1 while I is less than 25. Print touch rack i.yaml, because I just need to create these files. Oops. Oh, fprint, and then I need to increment. Plus equals 1. There we go. So I'm just going to paste this and copy this and then paste it into. I could have loaded up a Python module that can interact with the file system, but this was way easier. Oh yeah, group vars went into the wrong directory, so I'll move that. And I'll just paste it. So now my group vars, I should have, yeah, rack 1. All right, cool. All right. Rack 24. So we've got our group vars set, at least the file name set. So let's start populating it. And we'll go in via, we'll use one of these, examples here. All right, so I need to make some choices. I'm going to need, for the underlay and overlay, I'm going to need some loopback 0 addresses. I'm going to need some loopback 1 addresses. And I'm going to need some point-to-point addresses. So the loop, every leaf will get a loopback 0 and a loopback 1. Every spine will get a loopback 0. So anything that's going to be a VTEP gets loopback 0 and loopback 1. So I need some addresses to put in there. I'm going to use IPv4. I also, if I'm going to use BGP as the peering, as the routing protocol between the spines and leaves for the underlay, I need an IP address on each of the interfaces. So leaf 1 and spine 1, that's going to be an IP address here, an IP address here, IP address here, IP address here, IP address here. That's going to, I'm going to need a lot of IP addresses. We can do some more math. And I need, I have 48 times 2 times 3. So I need 288 addresses if I'm going to do this. So I need to give it a big range. So let's do, for loopbacks, I can just do something simple like a /24. So I'll do 255 0. I'll do 10.255 0 0/24 and then 10.255 10 /24. So that's enough because we only need 1 per. But the point-to-point, I need 288. And that's more than 256 addresses we find in a /24. So I need to give it at least a /23. I'm just going to give it something even bigger. I'll do a 22. So 0, 1, 2, 3 are going to be taken up by this point-to-point space here. And it's going to auto-assign them, which is really nice. It just auto-assigns them. So that'll be really nice. So I don't have to individually assign an IP address between every leaf and every spine, because that's 288 addresses I would have to assign manually, and that would drive me insane. So I'm not doing that. We're going to let AVD do all the work. That's what automation is for, is to let automation do all the work. Okay. We're 42 minutes in. Don't think I'm going to get this done in an hour. I'm going to shave 20 minutes off, though, because I'm doing a lot of lengthy explanations here. So, so keep that in mind. One of the reasons why I'm doing this is I think there are people that don't quite believe the time savings you get by doing automation. And I just wanted to show this as like, holy cow. When I started playing with AVD and I finally understood it and I was finally comfortable with AVD, you know, I'm comfortable with a lot of different types of automation, but when I was finally comfortable with AVD, it blew my mind, because now if I'm responsible for any sizable network with Arista equipment, I don't want to do anything but AVD. It's so good. Okay, so let's continue on with the fabric. Let's find fabric variables. So I'm just going to copy this and paste it in here, and we'll play around. So fabric.yaml. And the fabric name and the group name in the group vars and the inventory group all need to match. So it's fabric capitalized, it's fabric capitalized, and here it's fabric capitalized. So as long as they match, we're good. It also needs to match in the build playbook. So we're building fabric there. So okay, now this one file is going to build out the underlay and overlay configs for 50 plus devices, which is awesome. So these are, I think they're defaults. We're going to skip those. The underlay and overlay routing protocol is going to be eBGP. Those are the defaults, so we don't have to declare them, but I like to leave that in there just so we know what we're building. Local users, I want Tony there. What did it hash out into? Let's go to Tony at leaf 1. We'll go to config mode and then username Tony, password I'm going to do a bad password here. So Tony123. Bang. Using Tony. Secret. Tony123 bang. It's a stupid password, but you know it's being broadcast. So, and I don't want to use. So I mentioned this in another stream that I'm doing. Is that they have tools now that can listen to the keystrokes and actually pull the passwords out of that. So I'm purposely using bad passwords here, and it's just in lab environments. Because I don't want to use any of my good passwords for this, because you could possibly figure out what it is by listening to keystrokes from a live stream. And this video is going to get posted too, by the way. So if you want to tap out, if you're like, you know what, this is way too much AVD for me for now, I'm going to do this in digestible chunks, I will post this video. It's going well enough that I'm not embarrassed by it yet. So, so show run. We can see what my SHA-512 hashed out to. So I'll just copy that and then paste in the SHA-512 hash. Tony, and then because this config is going to overwrite whatever's there. So the earlier playbook that I ran is not gonna stay persistent. So I need my user accounts to be in here. So under local users, and then I want to put in the did I do admin? Yeah, I don't need to do that there. So let's do admin to. No, you know what? And then I need to put in an SSH key. And I can just copy this. Yeah, that didn't look like that was enough. Yeah, I definitely missed a few characters. There we go. So create that user, and I'm going to make sure that this is the right key here. So what I'm going to do is I'm going to go into the documentation, and I'm going to go into CLI config gen under input variables, and then authentication. So local users, and then I'm going to look for SSH key. Oh, that's radius server, local users. SSH underscore key. So I'm glad I found this. SSH underscore key. I'm not going to do BGP passwords. We'll just kill that for now. I'm going to set the P2P MTU is going to be 1550. If you were doing physical switches, you would set it to the platform max of 9214. There's no reason not to do 9214, except in this environment, these are containers on a container, Docker, VM, network. For some reason, it tends not to like the really high MTUs. So I'm doing 1550. That's a standard MTU plus 50 bytes for VXLAN. So that should, as long as we don't increase the MTU for our hosts, we should be able to pass any kind of frame that they want to send. I don't. Oh yeah, default interfaces. Oh, this is going to help me out a lot here. I haven't done this one yet. For spine, our uplink interfaces are going to be Ethernet. What are they? What did I set them for? So let's do show LDP neighbors. So Ethernet 3, 4, and 5. So Ethernet 3 through 4. And then on the spines, what did I set those for? To the others. Downlink interfaces. I think that, what is the downlink interfaces for? That was under examples. Build. Oh, sorry, fabric.yaml. Oh yeah, so mlog interfaces on node type. You know, I'm not going to set these. I haven't used these before. I don't want to like play around with them while I'm doing this here. So we're not using CloudVision, so there's no CloudVision instances. DNS servers, that's actually my DNS server, so I'll use that. NTP servers. I have one set up. Oh, server VRF will be management. And then that's my DNS server. I'm going to use got a couple other things I want to put in here. That I will copy from another setup. So just some other housekeeping stuff. So I'm going to put this stuff in under housekeeping. Because remember, we have to generate the entire config. Management API. So this drops me into, it does the same thing where it drops me into privileged exec mode. And then I also want the management interfaces to be on their own VRF. So this will make it so that all their management interfaces are management 0, goes on the VRF, and then the gateway for the management there. Oh yeah, I think that'll be my name server too. There we go. And because I have so many, I'm going to use yeah, so I need to put these in here. Otherwise, the routes won't get installed. And this is an issue with VEOS and CEOS. By default, BGP will not install any routes that it learns into the table until the hardware is initialized. But there's no hardware, so that's not going to work there. Okay, so next up is we need to define the spines, spine setups, and then the L3 leafs. This is where we define the topology and the underlay and the overlay. So for spine, for defaults, now this actually puts it into a different file, a different YAML file. I don't like doing that. I like to put them into I like to put it into its own, or I like to put it all into Fabric. So defaults, this will be CEOS Lab as the platform. The loopback IPv4 pool, that'll be, actually I think that's the same pool. So this is for loopback 0. And I think I specified that same address, 10.255.0. Yep. Oh yeah, I need an AS number. So all of the spines will have an AS number. And that'll be 65,001. And then the node name for each of the nodes. So this will be just spine 1. I need a unique identifier. And then here I have a management IP address, but it's in DNS or Etsy host, so I don't need that. and this will be spine 2. And then I need spine 3. And that's it. I've defined my spines. And my leafs, that'll be under L3 leafs here. I'll just copy this and paste it. This will give me the template to start with. CEOS lab. We'll use the same loopback pool, but I have to make sure that I don't reuse these ID numbers. I'm not going to do any offsets. The VTEP pool. So yeah, I'm using the same one. Oh yeah, I need to use /24s. So this is the VTEP addresses. And then all my leafs are going to plug into the 3 spines. So this needs to be a list of spines. So spine 1, spine 2, spine 3. Put them in quotes because they are, there we go. Spine 1, spine 2, spine 3. My uplink pool. So this is that really big pool that I was talking about. So this is 255. I was going to use 255. Or no, was it? Did I use 0? What did I use? I already forgot. 255, 0, 255, 1. Oh, yeah, this is overlapping. So this will be 0, 1, 2, 3, 4. I'll do 5 and 6. So this /22 will be it'll be 255, 0, 0 through 255, 4, 255, 0, so 3. So this will be 4 and 5, just to keep things tidy-ish. So let's go ahead and fix that. So this will be 4 and 5. And this is 255, 0 /22. So 4 class C's worth. So we got a question in chat. Is it normal for devs to go through the documentation while on the job, or are you expected to know everything? Oh no, you are not expected to know everything. You're expected to know where to find this stuff, and then some stuff you might be able to keep in your head, or more likely you've got I've already done this about 50 times, so I've already got all these files. So I'm just showing you how I would make it from scratch, but I probably wouldn't make it from scratch. So yeah, you're definitely not supposed to know all this stuff off the top of your head. You're supposed to know how to find it. Because let's take a look at all of the key value pairs in the documentation. So all these are key value pairs. There are so many options. It's like you're not expected to know every command in iOS or EOS or NXOS or something like that, but you need to know where to find this stuff. So great question. Because I don't remember this. I'm in this day to day, and I don't remember this stuff. We also need an MLAG peer pool. So let's do it 6.0/24. They're using smaller subnets because they don't need that many addresses. I don't like to give addresses smaller than 24 unless it's point-to-point links, because I don't want to do the math in my head. So, and then this will be 7.0/24. Everyone gets a 24. So 10.255, 0 through 3 is in this subnet. Then 4, then 5, then 6, then 7 for /24s. All right, we need a VMAC. I'm going to make this a 02 as the first octet for the MAC address. 02 indicates that that is going to be a locally administered MAC address, which means it's never going to be burnt into a chip. So the OUI for one of the OUIs Arista has is 001 Charlie 73. But there's no guarantee that there's not a NIC out there from Arista that, or an interface from Arista that has that as a MAC address. So if we do this, guaranteed, nothing will have a burnt-in MAC address of this. All right, spanning tree priority, all that. All right, so node groups. Rack 1. I could also do I can auto assign the AS numbers. So the way that we do it with eBGP as the underlay, every leaf or leaf pair, since we're doing the NMLAG, gets its own AS number. I don't want to have to assign them. So I'm going to do this. I'm going to do BGP AS. I'll do 65101 through 65190. So now it's just going to auto assign them, which is pretty cool. I could override it if I want to. I could say, you know what, I want this to be 199, and it would do it, but I'm not going to do that for that. Here's where I might use a script again. So we start at Ethernet 3, I think, on the... Oh, Ethernet 2. So it starts at Ethernet 2. And then Ethernet 3. You can see where this might be a... place where I might do a script. So I need to do 24 more of these, or 23 more of these. And I could just copy and paste and edit it manually. And I could probably actually do it quicker than I could do a script, but it'll be about the same. So I'm going to do a fabric make.py. And I like this logic here. So what we're doing is we're making where to go, group bars, fabric. We're making this. So I'm just going to copy this into the script as a reference, so I don't have to shift back and forth. Actually, you know what? I can do this. This is a neat thing we can do in the editor is open to the side. Yeah, I'll do that. And then fabric make. So the first thing we need to do is see how many spaces. 4 spaces. And we need to say this. Group rack I, or rack counter. So that'll be the rack counter, and then the next line needs to be nodes. Excuse me. Oops, didn't need that. Just indented so it's flush with the G. And then we can do the odd even counter. Yep, that's looking. Yep, looks like we can repurpose most of this. And then it needs to say name leaf leaf counter. We need to start at 10. So I need to create a leaf ID equals leaf counter plus 10. Let's create a new variable. Because that ID can't overlap with the spines, and the spines have 1 through 3. ID then leaf counter +1, and I'll just do this. Yeah, I think that'll do. See if that does what I want it to do. I have a feeling it's not going to work exactly the way I want. Python 3, utility scripts, make fabric. That's pretty close. I just did too many. Leave 39. Oh, because of this, I didn't need to do any of that. Did that work? Firing on all cylinders today. I can't believe that worked. So I just got to copy this and paste it. Yeah, there we go. We're almost done with making the config. I'm going to add another thing to here because we are going to do mlag. I think that might be the default, but we can specify just use mlag. I'd also want to set up the border leafs. I'm not going to put them in mlag. They can be, but they oftentimes aren't because they're peering with external routers and they don't need to be in mlag pairs. So I will do, actually, no, yeah, let's go ahead and make them mlag. So this will be group border leaves. And that'll be border leaf 1. 59, 60, 61. Okay. So we added the border leaves in there too. I think that's about it. This will be enough information to build the underlay, overlay, and everything else. Yeah. So this will build the topology, underlay, and overlay. I need to add a couple of things to our we're almost, this is just about the last of the hard part. For our spines, I'm going to set some variables. Type is spine. Then leafs, I'll set a vars type. This just tells Ansible, or tells Pi AVD which what type of what's the word I'm looking for? What type of template to use? All right, so Ansible playbook build. Let's see if this will build. Okay, so does not have downlink interfaces. Thought we set that. Maybe that's new in the new version. Should have used a version I've used before. So uplink interfaces is not set on leaf 1. So did I? Oh, you know what I didn't do? Yeah, that's what I didn't do. So fabric. Yeah, so these, I'm missing something here. So these need to be uplink. I thought I had uplink switches and then uplink interfaces. So I'm missing something, interfaces. And that'll be, I think that's Ethernet 3. Ethernet. Well, let's go on to the, and then show LDP neighbor to see what I'm connected to. It's 3, 4, and 5. 4. Ethernet 5. And then I'm also missing one other thing because we need to tell the fabric uplink switch interfaces. So that's the interfaces on the spines, and they're going to be unique. So if I go to spine 1, show LDP neighbor. Starts at Ethernet 2. So it's symmetric, so it's Ethernet 2, Ethernet 2, Ethernet 2. So what this means is that leaf 1 is connected to spine 1 and spine 2 and spine 3. So spine 1 and Ethernet 2, Ethernet 2 on spine 2, Ethernet 2 on spine 3. And this one will be 3, so we need to count it. So we need to go back to our little utility and fabric make, and we need to count it. So then we need spine interface equals 2. Counter. So we need to have a third line here. So print uplink. It's uplinked switch interfaces. Ethernet this one will be spine int counter because it starts at 2. We actually don't have to put them in quotes, so I'm not going to put them in quotes here. And then we increment the spine interface counter. Again, there's probably a better way to do this, but this is just the kind of dumb, simple way I'm doing it. Okay, I got an error in here. Oh, I need that there. And oh, I don't need that there. What did it not like? Oh yeah, I misspelled print. There we go. Perfect. Except it's not counting right. Oh, because there we go. There, that's better. All right, so I can just replace all that again. And then that's just in fabric, and I'll just try to build that. Oh, I did something wrong with the formatting, with the indentation. Node groups. There we go. All right, so that should fix that. MLAG interface is not set on leaf 1 for host. Oh yeah, so I need, if I'm going to do MLAG, I need to set the MLAG interfaces. So Ethernet 1 and 2 on all the devices are plugged into each other for MLAG. Oh, look at that. Boom. Cool. So that's an Ethernet underlay, overlay, and we haven't done the EVPN services yet. So let's go ahead and deploy this and see if it works. So I'm going to check. I just created that one command, this command right here, build fabric, just created configurations for spine 1, 2, and 3, and leaf 1 through 48, and border leaf 1 and 2. So we're going to look at intended and just going to give this a quick looky-loo. Make sure that I've got accounts in there so I can get logged in. Do I have a... Oh, crap. I don't have a management address. I don't have a management address. This would not be good. This would this would log me out. So I do need something else in here. And yeah, so I need to specify management IP. Because otherwise it won't put the management address in there. So it's always good to check to make sure that you generated, again, this config is going to replace whatever's on the switches right now. So if I don't have a management interface on there, it's not going to have a management interface, and I'm not going to be able to log in. Ask me how I know that. So I need to fix my generate script again. Luckily, I started from they're sequential. So management IP be 172.20.20 dot management IP. So management IP I could just reuse leaf ID. Yeah, so if I go to, right now if I go to admin at, or a Tony at leaf 48. Show IP interface brief. The management operator should be 58, and it is. Okay, so that crisis has been averted. So this is fairly typical to how this goes. Now, you'll notice that we're spending a lot of time on the stand-up, at least on the setup of this. But once we get going, once this is done, this work we don't have to do again. There we go. So let's try to build those configs again. And then we're going to check. I just built 50 plus configs. How long did it take? How long does it take to build 50 plus configs for devices? Ten seconds. Plus the hour hour and a half I've spent doing this. How long has this stream been on? Streams have been going on for close to an hour and a half. Now, this is all you would need to do for a production environment. So think about, you just got 50 switches. They've been racked, stacked, and cabled. You did the initial config. You got the initial IP addresses on them. And then you're like, I need you to build out an EVPN VXLAN network. 90 minutes into it, we're almost done with the underlay and overlay. You could not do this manually in an hour and a half. You'd probably have a couple of leafs done by this time. So, you know, what I would like to do is I would like to find a skeptic of automation and just challenge them to a duel. Like like my automation versus you doing this by hand. How long would it take you to stand up a network? How long would it take you to modify a network? I bet I would beat them like crazy. Okay, so let's take a look at the configs. The most important thing is management 0. It's in the right VRF. I've got an IP address. And I've got, do I have user accounts? I do. I probably want to put admin in here. Yeah, let's do admin. Just have another account in there. So I need the SHA-5 for admin. SHA-512 secret for admin. And I'll copy that and we'll put that into the fabric file. Where are the users? Where did I put that? Yeah, put that here. So another user name will just be admin, privilege 15, role network admin, and then SHA-512 password. Yeah, put the key in there too. Doesn't hurt. All right, moment of truth. Now this is kind of the scary part. Is I'm going to deploy this baseline config to the devices. This will be the topology, underlay, and overlay. It's not the services yet. We haven't done that. But if I did everything right, I should be able to log in after I'm done. If I did this wrong, then I'm going to lock myself out. So, it's not a huge deal because I can just respin up the container lab. But let's give it a try. I need to do a deploy playbook. I don't have one yet because it's blank. So let's go into the documentation and we'll go to the examples, single DC L3LS. And this is what the deploy one looks like. We're going to use the API. We don't need gather facts. So we're going to deploy via eAPI. And then let's see if this works. Ansible, playbooks, deploy. I'm going to do one more quick check. Make sure I got user accounts. Oh, you know what I could do? This will make me feel a little bit better. I haven't logged into Leaf 2 yet. I'm just going to copy. I'm going to config mode. I'm going to paste this generated config. And then see if I can still log in. I can't. Okay, so that gives me some hope that this is going to work. All right, so let's try. Yeah, let's try that. Oh, it didn't generate, it didn't get the admin. No, because I hadn't regenerated it yet. So now I'm going to try the same thing. Okay. All right, I think we're good. So let's do Ansible playbook deploy. So this is going to deploy it to all the devices. It also does a backup of the configs. Okay, so I got an error here. Oh, so the problem is I didn't put a subnet mask on the configs on the management interface. So if we look at management 0, yeah, I didn't put a subnet mask on there. So what I do here is I'll have to redo it in the touch here. I need to do it here. I could go into each one of these. There's not a quick way to do that though. So that's 24. So I'm just going to erase this and remake it. There we go. So what it was is I generated syntax that had a syntax error. So I just had to fix that. Again, this is fairly typical for how this all goes. Let's try that, make that command again. So we'll do a new build and we'll look in the intended on the config, and what I want to see is the /24 show up. There it is. So I just rebuilt all the configs, and now let's go to deploy fabric. And while that happens, I'm going to go into spine 1, do watch 1 show IPBGP summary. Look at that. My underlay and overlays is getting complete. So let's do show BGP summary. System's kind of lagging because I'm doing quite a bit. Look at that. Look, all those, they're starting to come up. CPU is probably pegged right now because all of these nodes are running on one physical system. We're almost done. Hour and a half. We're shy an hour and a half. It's 87 minutes, and we're almost done with this entire thing. My underlay is complete. Okay, now we're getting some errors here. What might have happened is I need to change the... So command timeout triggered. Yeah, I think I probably locked myself out. Leave 45. Connection refused. This might be a CPU problem. Yeah, I think I just overwhelmed the CPU because the interface is there. All right. Yeah, I think it just blew out the CPU. And stuff was timing out. Oh yeah, that is. Oh, NTP. That's what's causing all this stuff. Look at that. All right. I'm going to make a new config, and I'm going to turn off MTP. I wonder why NTP is going crazy like that. So let's do group vars, fabric, NTP. I'll just turn off NTP entirely. Maybe my I have an NTP server set up locally. It just may not be working. I may have forgotten to turn it on. So I'm going to build configs. Yeah, the system's running pretty slow because all the NTP services are killing it right now. You know what I'm going to do? I'm going to do this. Let's have some fun. Sudo kill all NTP. And then I'll try building. I just killed all the NTP processes and all the containers. They might restart, but this will give me a chance to... All right, let's try to deploy that before everything restarts. That would not happen on a physical deployment, because on a physical deployment we have 50 devices. Each of them have multi-core processors. So even if the NTP process went crazy, it wouldn't go crazy times 60, which is what happened here. Okay, so now we've got a deployed config. So if I SSH as Tony at leaf 44, show IP BGP summary, everything's working. So underlay and overlay is complete. And one of my lights just went out. So now we just need to do EVPN services, and we're almost done. So here's our logical topology. We've got 3 VRFs. We'll put them all under one tenant. Tenants are they're a boundary. Tenants are a administrative boundary. They don't actually show up in the config anywhere. Let's look up the services. Network services. They call it network services. That's fine. And I'll just copy this. So this is going to go in group vars under EVPN services. Tenant, we'll just call it tenant 1. We'll use that. We need a base VRF VNI base. 10,000. Here's the VRFs, and we're gonna keep this. This is from my live stream earlier. I'm gonna keep this in a different window. So it's DMZ is the first one. We need to give it a VRF VNI. We're not gonna do the diagnostics. We don't need that. SVI is VLAN 10. We'll just call it VLAN 10. It's enabled, and we have an Anycast gateway. We'll do 10.1, 10.1. So that Anycast gateway will be on all leafs. VLAN 20. You know, I could, if I was going to be really clever and I had a lot of these, I would have like people put it into a spreadsheet, and I'd run a script on the spreadsheet and generate this dynamically. So that's what this is here. So the VRF is DMZ, DMZ, VLAN 10, 2030, 10.110, 10.120, 10.130. So that looks good there. So the next VRF is going to be internal A. And we'll do 11 for that one. No VTEP diagnostic. And we've got more. We got VLAN 100 through 106. So that's pretty easy. 100. VLAN 100. I could make a dumb little Python script to do this, but I think just copying and pasting would be fine. Sometimes it's not always obvious what can be a Python script and what can be just copying and pasting. It's not too many here, so. All right, so that's 105 through 106. That looks good. And then we have internal B. And it's VLAN 200, 201, and then we've got 202 and 203 that are L2 only, so that's no problem. So 200, and then 200, and then 201. Oh, I fixed that there. And then VLAN 202 and 203. They don't go into a VRF because there's no routing for them. They're just a layer 2 extended domain. And then we could give them more creative names if we wanted to, but I'm just going to stick with this. All right, that's it. That's the services. And then we need the endpoint connect. We need to configure these endpoints. By the way, that was it. That was all the VLANs and Anycast gateways. That's all done. And that took like 5 minutes. Now we need the endpoint, the profiles. So that'll be endpoint connect. We'll go into connected endpoints. Do they have a profile in here? No, they didn't use profiles. So we're going to use a profile though. So we're going to go into EOS designs, input variables, and we're looking for endpoint connectivity, port profile settings. We'll look for the YAML and we'll copy that. We'll paste it and then we'll figure out what we need. All right, the first profile will be DMZ profile, DMZ profile. We don't have a parent profile. We don't care about speed. We'll do auto detect. We can do a description, DMZ. Enabled. Default is true. If it's not true, it'll be disabled. So we'll just go ahead and leave that enabled. The mode is going to be trunk. So we'll pass multiple VLANs to it. We'll do VLAN headers. We're not going to set an MTU. We're going to let it to be the platform default. We're not going to do a native VLAN or native VLAN tag. We're not going to do phone settings or trunk groups, but we do need VLANs. And for DMZ, that is VLANs 10, 20, 30. So 10, 20, 30. Port fast is edge. The rest we can leave default. We don't need QoS, point P2P, SFlow, flow tracking, link tracking. These are all options that we have that we're not going to use. I think we're just, there's a lot of options you can set. power over Ethernet. We're not going to do that. Storm control, we don't care about that. Basically anything that you would normally do in a port channel. We are going to do a port channel. Do active, because it will be LACP. We're not going to specify an ID. I think that's it. Endpoint port channel. We don't need even that even. I think we can just skip the rest. Yeah, we're done. All right, so that's port profile. We'll do the next one will be internal a VMware. And it is 101. Track down 101, 102, 103 for VLANs. You know, for VMware, we typically actually don't do a port channel, so we're just going to leave that like that. It would be route based on port ID. Oh, 10 people watching. Hello, everyone watching. So if you're just watching, I'm challenging myself to do a AVD configuration. I was going to try to do it under an hour. We just hit just over an hour and a half. But going from zero or just basically basic config, just enough to log into a Leaf, but no EVPN, no routing, no nothing, to a fully fledged EVPN VXLAN network and try to do it in under an hour. I couldn't quite get that. I think if I weren't explaining things, I could probably maybe sneak it in under an hour. We're about an hour and a half now. It took about 20 minutes to explain the whole thing in the beginning. So, but this is still really fast for getting all this done. Then we need just another, we need B. So let me know if you have any questions about what I'm doing here. You can ask me in the chat. And this will be the firewall group. That will be a port channel. So these are just going to be port profiles. We don't have to use the profiles. We can override it. But these are, it just reduces the amount of YAML we do. So now we just go rack by rack and we say what kind of, how we are going to configure everything or connect everything. In AVD, we have two different ways that we can describe how we plug a host into the fabric. We can do it network style, or we can do it host style. So network style is very similar to what you're used to in terms of network ports. So it would be like the switches and then the switch ports and then the profile that we're using for them. So we can do it that way. The other way to do it is to do it from the perspective of the endpoints themselves. So I could say, what's the endpoint? It's ESXi host 1, ESXi host 2. So we reference by port, by switch and port, or do we reference by host? And they both work fine. I've done it both ways. So I'll give you an example. I'm just copying and pasting from example I've got here. So for like rack 1, which is leaf 1 and 2, host 1 is plugged into, don't need that, Ethernet 7 on leaf 1 and leaf 2. On VLAN 10, it's an access port. So that's one way to do. We could do it by the host, or we could do it by the. Instead, we could do it by the network port. They both can do. They both end up with the same config. It's just what perspective does it make sense to keep track of. So this would be like leaf 1 and 2. Ethernet 7, which VLANs. You know, we could do it this way. We could specify the profile. I do have I did have what we were going to do was these profiles here. Let's see if this will work. So rack 1 and 2. So leaf 1 and 2. Ethernet. See if this will work. Ethernet 3 through 10. And we'll do profile, network port settings, profile. Let's give it the name. Okay, profile. It was DMZ profile. So leaf 1 and leaf 2 to do that. So rack 1 is leaf 1 and 2. So we're gonna keep it just to that, and I think that would configure leaf Ethernet 3 through 10. Let's see if that does that. I do need to modify something in the inventory. So in order to build out the EVPN, VXLAN, EVPN services and endpoint connect, I need to add something to the inventory. By the way, what I'm going to do right now is I am going to, just so everyone can follow along, is I'm going to do get add everything, get commit, second commit, and then get push origin main. Now it's on the, now all of this is on the GitHub repo. So you know I've got everything on the GitHub repo. Which is, let's do github.com, Tony Bourke. And here's that demo right now. So that's all, everything is here. So the inventory file, everything is here. So I do need to add something to the inventory file though. Parallel to these groups, I need to create 2 new groups. EVPN services. Children is all my leafs. Then endpoint connect. Children is all my leafs. So Ansible playbook, build. So the process is build, deploy, and then we'll also test when we're done here. Let's take a look at what we've deployed. So you can see the VRFs are in there now. And we got the port channels. Yeah, the port channels and their MLAG port channels. Yeah, that did it. Easy peasy. The VXLAN part's all there. Now I'm going to, the hosts, if I go into Tony at host 1, show LDP neighbors, I'm plugged into, on Ethernet 7, I'm plugged into leaf 1 and 2. I'm also plugged into leaf 3, but I'm going to ignore that. So I'm going to make a new config here. Rack 1. 366, 8 through 10. So on Ethernet 7 and Ethernet 7 on leaf 1 and 2, I'm going to do a config here. So it'll be VLAN. We're just going to do 10. Mode is going to be an access port. We're not going to do anything fancy. It will be a port channel. Mode active. And then for host 2, what are we plugged into on host 2? Leave 5 and 6. So I'm going to copy this. Oh, this will be, we want an existing VLAN. So we'll just put it into, yeah, DMZ. It's 1020. So leave 5, leave 6. On Ethernet 7, VLAN 20, port channel. And this is going to allow host 1 to ping host 2. That's the goal here. Let me just throw a quick config on here. Interface port channel 1 through 2, or Ethernet 1 through 2, channel group 1, mode active. Port channel 1, no switch port, IP address 10.1.10.11, and then IP route 10.1.10.1. Oh, shoot, I'm on the wrong subnet. IP address 10.1.20.12. IP route 00.10.1.21. Write that, and then go to host 1. You can tell I've done this a few times. So you'll notice I'm not using any of this to configure the hosts, because hosts are typically configured via a different mechanism, by different means. So I'll do that. And then we'll go in and we will build the config again. And I'll just check leaf 1's config to make sure that we've got the port channel the way we expect it on Ethernet 7. It's not M-lagged. Oh, I messed up here. 345. Here's where I messed up. These are used by, we'll just do Ethernet. They're used by the uplinks. So I'm double configuring them, and that's that's bad. But that's only in leaf 1 and 2. So that's okay. So we'll build again. Leaf 1 config. That's better. Because it's I had them, this one actually might actually happen. So I said ports 3 through 10 I'm going to use for this endpoint connection, but I forgot that ports 1 through 5 were used for uplinks and crosslinks. And I want to do one more thing. Port channel ID. Yeah, port channel ID. Make that 7. Let's try that again. Build. So I'm trying to give it a port channel ID manually. How did I do that before? Enabled port channel active. Or maybe it's here. Port channel ID is 7. I'm missing an mlag. It should say mlag 7 here. So let's check it out here. We'll go to examples, see if it's listed in here. Because sometimes one of the issues you might run into is that you'll notice that there's something missing in the config and you're not sure why, how to get it to spit that part out. So we're almost done here. Yeah, it doesn't look like it's doing. L2 leaves, network services, servers, port channel, endpoint port channel. Do a quick search here. So I'm going to go to one of my previous, because I probably already solved this problem. Let's go to one of my previous repos. Got an AVD playground I've made. Some multi-DC, group vars, endpoint connect, spanning tree. Let's copy this wholesale. Let's try that. Yeah, that worked. Okay. Yeah, that'll work. And then all 3 and 4, I'll do that there. Just paste that. So this will be host 2 on leaf 5, 3, 4, 5, and 6. VLAN 20. Host 2. So that actually should build out that. Then if I go to host 1, I can't ping my gateway now because that config has not been deployed. So let's go ahead and deploy that config. Let's see how long it takes to deploy. Again, we just made a change to, we're making a change to like 50 devices here. "30 seconds. And now I should be able to ping my gateway, and I should be able to ping the other host. Can't ping back and forth. Oh, I've got 2 default gateways, that's why. IP route 10.1, 10.0 is 10.1, 21. Now I should be able to ping my other side. There we go. Yeah, so Fabric's working. EVPN, VXLAN Fabric all set up, pinging back and forth. And then it would just be a matter of how we would configure the ports. So I'm not going to do that for 2,900 ports. Another thing we would do is we would configure external routed connections, and then I think we'll call it a day there. So where are we at in the stream? We're at 2 hours. So we're at 2 hours, and we went from 0 to fully functioning EVPN VXLAN network. The last thing I'm going to do before we shut this thing down and break out make it cocktail o'clock, is set up the routing between these here. I'll just do R1. And so if I log into R1, what am I plugged into? Show LDP neighbors. Border leaf 1 and 2 on Ethernet 6. Okay. So, and I'll do it on DMZ1, just the DMZ. I'll do, so this will be L3 interfaces. So to give you an example, to give you an idea of what I'm doing, on border leaf 1 and 2, it's Ethernet 6. So I'll just make a quick diagram. Then I've got border leaf 1 and 2. So they're connected to each other. So the connection's already there. I'm going to put, this is R1, I'm going to put a network, just a dummy network on there to represent the entire network, internet rather, 16.0.0/12. And there will also be 16.0.1 on there. So that'll be our pinging to the internet. That'll be on a loopback or a interface VLAN. So we need to do some BGP. So I'm going to do 10.1.50/31, 10.1.5.1, 10.1.5.2, 10.1.5.3. So those will be the IP addresses that I'm going to use. And then that's configured under L3 interfaces under the VRF. And I got this from under CLI config gen. No, it's under designs, input variables. And it's under L3 node L3 node type BGP configs. L3 edge. So on Ethernet 6 on nodes leaf. Actually, you know what? Border leaf 1, border leaf 2, Ethernet 6, because I can specify more than one IP address at a time. IP addresses. It wants 10.1.5. What did I set? 0 and 2. 0/31, 10.1.5.2/31. So that'll put a layer 3 IP address on border leaf 1 and border leaf 2. Misspelled border leaf there. Border leaf 1, border leaf 2. And on Ethernet 6 on these two of those IP addresses. And then we just specify our peers. So this will be our BGP peers. IP address 10.1.5.1 will be the router 1. Remote AS, I'll just make it AS1, make it simple. And nodes will be on leaf, border leaf 1. Then another IP address, 10.1.5.0.1.2.3. So 3, not 0. 3. Mode AS1, nodes, border leaf 2. So setting that peering up, that'll set all the BGP stuff that we need. And I need to configure R1. So I'll do Tony at R1, config, interface loopback 0 IP address 10.255.255.254. I just need a router ID. IP routing, router BGP1, router ID is 10.255.255.254. Interface E1, IP no switch port, IP address 10.1.5.1/31. Interface E2, IP address 10.1.5.3/31. Oh yeah, no switch port. Router BGP 1, neighbor 10.1 1.50. So what is the SSH add Tony at borderleaf 1? Oh, I didn't think it's in the inventory. Yeah, we didn't generate a config for it. Oh, that's right. I overrode it by accident. So SSH admin at borderleaf. They have no config on them. What did I set? Yeah, so let's go ahead and get a config on them now. So we'll do build fabric. So we should see 2 new nodes, Ansible expected list of your BGP or nodes. Oh yeah, I didn't put it in brackets. When you see an error that says expecting a list, so I gave it nodes, but I gave it 1. So a list, I put it in brackets, or I could put it in dashes. So that should do that. Oh, and for the fabric, I didn't put in any, any of these for border leaves. So 50. Or what are they on? $52, and 53. Pretty astonishing how many nodes that Container Lab can handle. I'm quite impressed. Yep, we got border leaf configs now. And we just didn't have any before. They weren't in the inventory. And let's do deploy. It's about 30 seconds for that. Now I'm going to go into border leaf. Oh, crap. I forgot to put a management IP address, so that will be a problem. So one of the problems with automation or challenges is that garbage in, garbage out. So if I give it bad information, it will configure bad things or lack of things. Like I needed to put in the management IP address. Luckily, so we'll just build that again. I can still get into them. So it's sudo docker exec it border leaf 1 CLI. So just interface management 0 IP address or VRF management IP address 172.20.2091. Do the same thing for border leaf 2. This is kind of like my back end, it's It's a way to get into Docker containers when you've locked yourself out. You know, you can tell I have that command memorized, so it's something I've done a lot. So try deploying again. Yep, there we go. And if I do show BGP summary, we're established. So we're 161. That's our AS number. So that's all I needed there is, so I go to our config show run section BGP. So neighbor 10.150 remote AS is 65.161. I think that's what it was. Yes, 65.161. That's the AS number of the border leaf. I can override it. I can set it to something more specific, but 161 is what it is. A neighbor, and then address family IPv4, neighbor 10.150 activate. I'll do interface VLAN 100. No auto state, IP address 172.16.01/12. Just do /24. And yeah, because I didn't put it into a management VRF. And then under router BGP, address family IPv4 and network 172.16.0.0. That should announce it in. So show BGP summary. It's established, and then I'm sending routes. Show IP route. So I'm getting routes. I've got the routes from the VRF. And I should, from host 1, be able to ping 172.16.0.1. I can't. Oh, yeah, I need a route for it. IP route 172.16.0.24 is 10.1.10.1. Is that what I put on there? Should be announcing it into it. So I'm going to go to the border leaf, show IP route, VRF, DMZ. Yeah, I'm getting that. Oh, did I put the brief? 172.16.0.1. So I'm getting this route 172.16.0.0/24. I got it from R1. And if I go to leaf 1, do show IP route for VRF DMZ, we should have that route in there. It is. I'm not sure why I can't ping it. Might be because these routes are overlapping. Am I gonna do? No, I think I could. Yeah. So no IP route 172.0.0.172.20.21. Yeah, I'm not sure why that route's not working. Oh, could it be I can't get to the other side? Am I getting that? Show IP route. Yeah, yeah. So the routes are there. I'm just not sure now why it's not pinging. But I'm not going to worry about that now. We're at 2 hours. I think we're good to go. probably just something I'm missing here. But this was a phenomenally large, you know, the 50 switches. That's a big deployment, and in 2 hours I'm almost done. So most of the stuff is already there. So let me go ahead and do a get add, get commit 3, get push origin main. Oh yeah, another thing I'm going to do is I'm going to show you my the actual topology. So I'm going to put that into topology, and I call this CLab, or I call this clo-huge.clab.yaml, and that is it right there. There's no IPv6 subnet. I don't configure an IPv6 address through AVD, and by default, Linux will try the IPv6 address first. It takes like 6 seconds to time out, and then goes. But this will be easier. So, all right, let me do the get add dot get commit added huge topology. Get push origin main. All right, I'm going to shut this stream down. Hope everyone enjoyed. My guess is that many of you just had it in the background. I will. This will be posted, so all of this will be on there, and the GitHub repository is in there as well. So, thank you for watching. Thank you for sticking around if you stuck around.